Okay, YouTube, in this video, as we continue to get into matrix operations, we're going to start by just talking about a pretty simple concept, and that is the equality of matrices. If we have two equal matrices, what would be true about them? So two matrices are equal if and only if, okay, they have the same order. So the stipulations are that we have to have the same dimensions, same rows and columns. And we say that corresponding elements are equal. So that is to say, if we have two matrices A and B, we would say that A is equal to B if and only if they have the same order, okay? But also if Aij equals Bij for every row up to the mth row and every column up to the nth column where we have m rows and n columns. So that is to say that when we look at these here, basically if we have two equal matrices, then every element that happens to be, say, in the third row, second column would have to be the same thing as the thing over here in the third row, second column. Or in general, we would say that in the ith row, jth column, that element here would have to be the same as the element corresponding to it in the other matrix if these are given as equal in the first place. So just as an example here, let's take a look at this down here. It says A equals this matrix here, and it looks like we have a two-row, two-column matrix. This is actually just a one quantity there, y plus 1. So we would say that this is a 2 by 2. And our B matrix here looks like we have, this is also a 2 by 2. So we say that if A equals B, okay, then we could say A equals B if and only if what? And so what can we conclude about this? Well, what we know is that corresponding entries have to be equal. So that is to say that this X, because it's in the first row, first column, then it would have to be the same as the entry over here in this B matrix in the first row, first column. So because A11 equals B11, then we could say X equals 1. So I'm going to put a box around this. I'm going to say X equals 1, but what else could we conclude? Well, Y plus 1 and 5. If Y plus 1 has to be the same thing as 5, you could see how now we could work backwards and solve for some unknown values in a matrix, which really is the algebra part of this. And so we'd say, and of course, Z is in the second row, first column, and so is 3. So Z is equal to 3. So what I want everybody to see is that if we go back to A here, and we make these substitutions, that is to say we had X, okay? Our next entry was Y plus 1. I'm going to expand this a little bit here. We had Z, and we have 6. If we plug in for Z, 3, and we plug in for X, 1, and we plug in for Y of 4 here, you could see that this comes out to be the very same matrix as B. So if two matrices are equal, then their corresponding entries have to be equal. Cheers.